So since we're moving on to actually tuning on the mass spec, I thought we'd go over a couple of things that we're going to be changing the voltages on while we're clicking around over there. So this is the whole layout of the instrument. What we're mostly going to be adjusting when we are tuning are slits in this transfer chamber here, and that's kind of given there. So we're going to be adjusting things in the expansion chamber, the HV3 chamber, and the transfer chamber. And you'll see those tabs in the high voltage tabs and in the source slits. After the magnet, you'll see zoom lens 1 and zoom lens 2. Those are depicted here on the right. Quad 1, which is your major shape changer when you're tuning, you're just going to change the quadratic voltage on zoom lens 1. So this is a big one for us when we're tuning. You may want to adjust zoom lens 2 if your high and low masses are not really matching up and nothing you're doing with linked quads will bring them together. That's when you're adjusting zoom lens 2. And those will be Q16 and 15 correlations. They just adjust how the zoom lens 1 relates to zoom lens 2, as you can see here in this schematic. Now we have a vision of what we're moving around. Let's get tuning. Now we're on the new computer. So I'm just gonna recap a couple of things that are important. Over on the left is the plasma control. We can make sure it's lit here by making sure that's red. We've used this VAC button, we've checked reflected light, and we're gonna hit a couple of other things for the torch over here later on. As we move down, again, we'll see these valve controls, and we'll just reference our pressures here. Over to the far right, you'll see IC supplies. This is where we turned on our protection earlier. Up on the top right, you'll see the digital control, where we enabled our ion counters, where our high voltage units and source got enabled when we first turned it on. And we're going to be using a lot of these deflector and high voltage supplies over here and the supplies control window later while we're tuning. Now we're going to just make sure we're on our right tune setting for whatever we're doing, and we're doing uranium lead with Faradays. We'll go to Setup, Constants, Tuning, Initialize. And we're just going to pick the most recent tune file for whatever we're doing. We're going to do Faradays, so we'll just pick that guy. That's at the very top. And then we will say Open. All of our deflectors and high voltage supplies will update to that tune setting, whatever those were set at. Similarly, if we move to the left under our plasma control, various torch positions and mixed gas settings will also update to that original tune that we've just loaded. Once we've opened the tune file we want to start with, we'll go to Scans, Magnet, and that's going to scan across the range of masses that we're going to be using. What you'll notice is you have a start scan reference mass and an end scan reference mass. You may need to update those depending on what was previously tuned for before. To do that, you'll go to Edit Scan, and you'll just update it to, we run between 214.3 to 214.3 or 215.3. But depending on where the mass actually is, where all of our signal is reading, we may need to change that. So we'll leave it at 214.5 and 215.5 for our Faraday tune. And we'll just save that edit. And let's enable the grids. It's just a little bit easier to see intensity changes with the grid on. So you'll just tick grid. The last thing we'll want to make sure we have ticked is the appropriate Faraday cups and ion counters that we want to watch over these isotopes. This EXH here, that's going to be our 238, that's our uranium. This H2 is 232 thorium. We'll also want to enable L6, L7, L8, and then ICO and IC2. But our main one that we're going to focus on during tuning is this EXH, our 238 uranium. I'm just going to go over to the laser computer and press Start Run, and then Start. And what you're going to see next, as it approaches the appropriate masses, is a little peak form of what we have checked. Now the problem here is that our scales are a little bit off, so let's go ahead and change that. To change any scale in here in this magnet scans window, you just double click on your min-max, whichever one you want to change. I want to change the max of my 238. I'll double click. It looks like we're coming in at about, let's wait for it. At about 500 millivolts. So let's put this at 0.9. Anytime you want to increase the height of your signal, you'll go ahead and bring that max number down. And anytime you want to decrease the height of your signal, you'll bring the max up. That's true for all of them. So in order to monitor signal, we have a couple of options. We can just, watch this line go up and down and set our min max, or we have this cool screen down on the bottom right corner. And we can monitor any of the Faraday cups or ion counters that we want live as it scrolls across them on that scans magnet window. So I have what I want now, but if I wanted to change it, what I would do, I'd come all the way up to the top left to setup. I'd click that. I'd go to monitor. I get the option to look at any one of these that I want up to, I think, about 6. I can watch 6 at a time. So I want to watch my EXH. If I wanted to watch thorium, I could add it in, and then I'd see it add in if I had room. So if I unticked ICO because I didn't need it, I'd add H2. And now if I move to the bottom right, you'll see that I have H2 instead of that ICO in there. But we don't want H2, so we're going to come right back up, untick H2, and put IC0 in there. And then we're just going to exit out of there, and now we're monitoring what we want to monitor. So now at its peak, if we look down and monitor our EXH, it's about 500 millivolts. And then it washes out as it cycles through. And we'll see it happen one more time. There we go. About 520 millivolts. So that's pretty low for us. So we got a lot of work to do here. The first thing you want to check is torch position. Anytime you have a false start or it just doesn't light right away, your torch will back up. So we're going to check our in-out torch position to see if it's backed up on us. So in-out is reading right here, and it's at 9. It's usually around 6 units, so it's sitting at 9 units now. So I'm going to go up to these toggles, these in-out toggles, and I'm going to move it in. The one thing I'm going to do is set that magnet on one mass point. When you're tuning and you're making changes, you want to be on the max signal. So I'm going to wait for this to go through my whole peak first, one time. Once it's reached the bottom, I'm going to stop. And to peak center, to be on that main peak and watch that over time as I change, I'm going to right-click on this dashed vertical line and drag it into the middle of our mesa. If you don't have a mesa, don't worry, we'll get one. So we'll leave it there. And then once I found my middle, I'm going to select Set Magnet, that button on the bottom right of your magnet scans window. And at that point, you'll see your start scan and your end scan reading the same exact mass. And that's what you want when you're trying to just get high peak intensity. So now we're going to go in-out and change that 9 and kind of move it in and see if that gets us a little better signal. So I'm going to just move it in a couple clicks at a time. Be very careful with in-out. You can totally break the torch. Don't do that. So just a couple clicks at a time. Looks like we're improving it already. We'll do a couple more. It's getting better. We're just going to keep going. You never want to get closer without looking than 6. Once you're at 6, you really need to be paying attention to how much you're moving in. So I'm just going to do a couple clicks at a time until I feel like we've lost any signal increase. And it's going to just take a while since we're out at 9. And we'll just keep moving it on in. There is a point at which that's no longer true, and then you're too close and you're kind of missing that sweet spot. So we're just going to move in until we find it. And it just keeps increasing and increasing, and at some point we're going to have to change that max so we can see how much better it's getting. We're at about 7.9 now. We can go at least a full 10 clicks before we need to start worrying about how close our torch is. And so we've reached our max here with what we've set for 238. So I'm going to go back over to this max, and I'm going to change that because I expected to get a lot higher after doing this. I'm going to change that to 1.5 millivolts, or sorry, 1.5 volts. And you'll just enter. And so now, since we've brought our max up, our signal now is down because it's much lower than our max set point, and I'm going to just keep on moving it in. So as I'm bringing the torch in, it's sort of changing the pressure at that point where it's entering into the cone. So that's changing our reflected light setting here. It's okay where it is now. I'll set it once we brought our torch into where we need to be, but if that gets too high, you know, past the teens, go ahead and take care of it by toggling back up and down 1 or 2 clicks. But right now it'll sit fine until I'm through adjusting the torch position. We are right along a crack right now, so we're not getting much signal increase, unfortunately, which will happen, and that's normal. The crystal is pretty heterogeneous. So I'm going to take care of reflected by toggling back up or down once, depending on what direction I need to go, whatever changes this value the most, back to 0. That's definitely the wrong direction, so we'll go back up, and now we're sitting at 0. We're happy, we're good. We continue moving that torch in. So a couple clicks at a time. All right, so we'll move in a few more clicks. We're getting into the dangerous territory of 6, so let's pay attention. So if you do find that you're moving it in really close in the 5.5, 5.6 range, it's probably because someone, it may have been you, pushed the bonnet back more than we're used to. And that's okay, but just know that 5.5, 5.6 is not a normal range for us to be operating in, and don't get comfortable leaving a torch there. And so I think we've reached our point at which we're finding the sweet spot. A little bit more out of it, but we've tapered off here, and I'm going to back it out just a little bit to see if it changes, and back it back in. Okay. So I think that's sitting its best at 5.75. And you can check that by backing it out and then backing it in a couple clicks and actually tracking that trend to see if it's consistent. If it's all willy-nilly, that has something to do with the crystal and nothing to do with you. But this looks good for us. Once we've moved our in-out position, the next step is to move our up, down, and our back forth positions on our torch. You have no danger of running into the cones when you're moving these, so you don't have to be quite as terrified. But still be mindful of what you're doing and don't click more than 4 times in a row. So these are going to be big changes at first, and then once you're pretty close to the operating range, you're not going to notice much differences. So we'll go up and down 2 clicks. I'm going to go up 2. And you can see your up-down changes here if you want to see that actual measurement. It looks like it got worse, but I'm going to make sure it's worse by going 1 more click. And it looks like it's still bad. So let's go down 3 clicks since we moved up 3 clicks. And there is one important point to mention with moving the torch, and that's that just because you moved 3 clicks up and 3 clicks down, you're not actually going to be in the same spot. Sometimes you need to go past the point that you need to go back and reach it. So that looks great. We'll leave it there. So our up-down position now is at 4.14. You may want to note these numbers as you're changing them, just in case you want to go back to the originals and see if it's actually better. So now we're just going to go to back forward. So that's moving it back and forward. And that's right next to back forward, unlike all the others for some reason. So we're just going to go up a couple. A little bit less signal there, and then up a couple more. Definitely worse. So let's go back to 2 more. And then let's go up 1, 2. So I kind of missed my peak a little bit, so I need to move it around back and forth just to get that sweet spot. And that has nothing to do with you being bad at reading the number. It just sometimes needs to move back and forth a little bit more to get into the initial position it was in. So this looks great, and it's at 7.28, which is what it started at, I believe. We're crossing one more crack, that's why you saw that dip. Let's just let that stabilize a little bit. So now we've moved everything once. You want to move everything one more time because they all relate to each other. So I'm still going to go through in, out one more time. I'm still going to through up, down, and back, forward, just to make sure those are really the right spots. So let's do in one more time. Couple clicks in, couple clicks out. Good. Maybe in one more. Let's go up, down, couple clicks. And then we need to find that sweet spot that we totally missed. Okay, there it is. And now let's go back forward, a couple clicks up, couple clicks down. So it's sitting pretty happy. Back forward did change just a little bit on that second round. So that's why it's always important to do it one more time. Now that we've gone through our torch position, it's always good to check your peak. Anytime you make big changes, physical changes within that chamber, it's always a good idea to check how your signal is being received. So we'll go back to restore range, and that's going to give us that full range of masses from 214.5 to 215.5. So let's go ahead and do that. We'll wait for our peak to appear. Definitely have more signal. Looks like we got a rounded shoulder here. This corner looks pretty okay. And then we sloped out. So the ideal here when you're tuning is not only to increase signal intensity, but to improve peak shape. And by peak shape, I mean, in an ideal world, you'd have a little box sitting up there with really straight sides, flat top, straight side, a little mesa. That is just not the way it works for longer than a day. So you're gonna get a little slope here, a little slope here as the signal comes in and out. And you may have some angling here on the shoulders as they come off from that top peak, but you want a flat top certainly at the very minimum, and you want to minimize the rounding happening at the shoulders here. And what happens over time is as your slits get worn, you're expanding the opening, which means a lot of material gets through, but peak shape kind of suffers just because your slits are no longer well defined. So there's a trade-off there between intensity and peak shape, which is where we're approaching now in this video. The slits have been in there for a little while, so we're getting a little bit more signal, but our shoulders on this peak are suffering just a little bit. There'll be a trade-off there. When they're brand new, you'll get tiny amounts of signal, but a beautiful peak shape. It's just the way it is. So we need to deal with this shoulder, certainly, when we're tuning, and if we can widen this peak, we're gonna try to do that. And we're gonna change that with our high voltage. So we're gonna go over here to the right to change peak shape and intensity. We're gonna use our high voltage here, and also our source, and also our quad. I'm gonna move the high voltage and sources over. This is not how you're gonna see them, but this will just be easier for viewing. They're normally gonna be over the right from where I pulled them from. So as I was saying earlier in our little demo, is that we are gonna change peak shape the most with this quad 1. We're also gonna change where it's sitting on this range of masses by moving quad 1. Just to demonstrate that, I'm gonna really kind of psych it out a little bit. I'm gonna move quad 1 quite a bit, and you're gonna see the changes here. So now it's moved over to the right. And it looks like we've lost a little bit of our width here on the top. And we've also need to change all of our masses and kind of put them underneath our 238 EXH mass. So I'm gonna move it back to 50 where it was sitting before, so you can see the difference. And this is where we had it originally. So I'm actually pretty happy with the peak shape other than that shoulder. So instead of adjusting quad 1 initially, because we don't want to push quads up if we don't have to, I'm going to go through source slits and high voltage units first. And then if I need to make some adjustments to peak shape, I'll do that later with quad 1. This is a very honed tune file. That peak shape is pretty good. We're not going to get it much better than that during this video. If it weren't, however, you might have something that, say, looked a little bit like this. I'm going to get crazy here and change quad 1 a lot. And what usually happens when you have lower quads is you have a volcano. If you have quads lower than you need for what you have going on in the mass spec, this is the sort of situation you're dealing with. And to take care of that, you'll need to change quad 1. You'll need to bring it up. So I'm going to bring quad 1 up a little bit. And you'll see that get a little bit better each time I bring it up. It's a little bit taller, a little bit less volcano-y. Our masses are getting closer together. Now, one important note that will also happen when you are dealing with something like that is generally these masses are already going to be underneath it. And to get masses underneath a quad 1, if they're not, is by changing linked quads. Now that moves lower masses underneath high mass, which is your 238. So 238, 232 here are not going to change when you press linked quads. At least they're not going to change in comparison to each other because there are high masses. And then all of our L's and our ICOs are going to change. They're going to move towards each other. So if I were to move linked quads, I want my low masses to meet up with my high masses, so they need to go this way. So I'm going to move them right. And you'll watch them walk across to the right as I change that, and then our high masses are going to walk a little bit to the left as I change that. But when you're thinking about changing linked quads, you want to think, which direction do I want my low masses to go, and that's what you press. So I want them to go right a lot, so I'm going to press that a lot. Another important note is to not change quads very drastically without also changing linked quads to match up. So what I just did, where I moved them all willy-nilly as an example of how bad it can be, don't do that normally. So you're going to want to move quads a little bit, then move linked quads to match up, then quads a little bit, linked quads to match up, and that's how you're going to go about business. And you'll see that each time I move them closer together and get them closer to the quad point that I know works, they're going to get a little bit better each time. So you can really get things out of whack if you're not sure which direction to go, and then bring them back together, and that's how you can convince yourself you're on the right track. Once you've done this a lot, you won't need to do that, but I needed to do it in the beginning, and so will you. So let's just put it back where we know they work. Quad 1 was at about 50.3, so we'll bring quad 1 up first. And just to stay true to my word, we'll move link quads too. We'll bring them over to the right just a little bit. Get those guys lined up first. They're getting nicer and nicer, all in a line. Move them a little bit more. We'll move our quad up a little bit more to match them up. Looking a little bit better. I'll move my linked quads one more click to the right. Peak shape's looking a little bit better. And so I could stay here and then go through my high voltage and source and then come back to see if I need to change quads a little bit more, because the idea is that quad 1 stays pretty low. So if I can keep it quad 1 at 4.6 instead of 5.0, that's great. So maybe let's start there. We'll do some changes and you'll see how that kind of affects peak shape and signal. So we're going to do the same thing we did with the torch. We're going to stop once we've gotten a full peak to look at. And then we're going to go set magnet by right-clicking that vertical dashed line into the center of our masses and then setting our magnet. Now, if all of these lines are distracting and you have no idea what you're looking at, you can untick them. You don't need H2, you don't need 232, you don't need all of these L5s, L6s, L7s, L8s. You can untick those, clear everything, and just be working with your 238 until you're ready to look at that full peak and see how it looks with all the other masses underneath it. And that's maybe the way to go when you're first starting, just to kind of not get distracted. So here's our 238 line. I'm going to go into my high voltage first. That's always a great place to start. So the first thing you're going to change is HV1. This is the weirdest one you're going to be changing because you're actually trying to find the center point for HV1. So it's sitting at 6018 as a voltage. What we're going to do is we're going to go 30 above that point and 30 below that point. And if those two changes are similar, then we know 6018 is the good mass. Otherwise, I'm sorry, the good voltage, not mass, it's not a mass. If that's not right, if they're really, really dissimilar, we'll maybe try a different midpoint like 17, and we'll go up 30 from 17 below 30 and see how that looks. So let's go up 30 from 6018, so it'll be 6048. Enter. And it should drop quite a bit, and then let's find the other side of that on the low end, which is 5988. And we'll wait till that guy gets there on the other side. And so there's a little bit of a droop. So let's see if we can make those two distances much smaller. So let's go 5987. And then let's go 6047. Now that distance is even greater, so I'm not on the right track. So let's go above 6018 and go 6019. Let's go to the high point of that, up, so 6049. And then the low point, 5987, sorry, 9. And so our distance is still a lot greater. So what that tells me is that 6018 is where we're gonna be for now. But we'll just check it, 6048, 5988, and that's our lowest distance. We're gonna go there. So our midpoint for HV1 is 6018. Now we'll move to HV2. HV2 and all the rest in this list, you're gonna change by increments of 5 and 10. You don't need to worry so much about one clicks. You really just want to see changes at this point. So anything that's making a good change or a bad change is what you're assessing, and then how much of a good change. So HV2, I'm just going to go up 5 clicks, 1, 2, 3, 4, 5. I can't really tell any difference, so I'm going to go up 5 more, 1, 2, 3, 4, 5. Looks like it's dropping. So I'm going to go back to that original 10 clicks ago, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Looks like the issue here is that we're going over a pre-ablated portion of the grain, so we're not really getting a good indication of our progress, that we're doing at least. So let's wait for that to stabilize. And since we're on the subject of stability, another thing you're looking for while you're tuning is a stable signal. So things like this, with big giant dips when we went through that crack, are not ideal. So if you're seeing a lot of noise in this line or any of the other signals for any of the Faraday cups or ion counters being an exception because they're so low that you're gonna see a lot of spikes depending on how you set your min and your max. You'll just wanna pay attention to how much noise you're seeing in here. And there's usually very little noise in the tuning signal if you have no other interference on your grain, like pre-ablated sections or cracks. So if you're like, oh, there's tons of noise, make sure you're not on a weird section of the grain. And if you aren't on a weird section of the grain, maybe pay attention to the last thing you changed and if that makes your signal much noisier. So if you're seeing a general signal that's stable, maybe a couple of hiccups here and there, you're probably on the right track. But if you change something and all of a sudden you've got mountains for days and valleys for nights, maybe reassess how smart a change that was. Something to note about HV2 is that you don't want to bring that up too high. if you also have your quads pretty high. So when I say pretty high, I'm talking about 50 and 60, about where we are now. So even though it might look better up much higher than 3609, it's not always the best idea to crank it up there. It tends to widen the slits even more over time. So my limit, usually I won't bring HV2 up past 3.7 something. So if I'm on 3.8 territory, I'm kind of like, nah. So let's just click it a few more times to see if we can improve it without damaging anything in the long term. Let's try bringing it up a little bit higher. So now we're at 3.709, and it doesn't really look better, so I'm going to bring it back down. So I think our sweet spot is about 3.619 or 3.629. I think 3.619 is much better. So we'll leave that there. We'll move on to HV3. Again, up 5, up 10, then back to the original, down 5, down 10, back to the original, and then pick your favorite spot. That is not the right direction. And neither is that one. So I think it's about where it should be, so let's bring it back up. And in your initial tuning phase, it's not a bad idea to write down all these original values and go ahead and check how far off you are from them when you look at the peak shape. That'll actually help you learn what you're really changing and how much it does when you change them to affect signal quality and also the shape. So we'll leave it at 4.387 for now. We're also getting a lot of noise in there, so we'll have to address how much worse that's going to get over time. So now let's move to HV4. I want to point out anything grayed out is something that's an instrument setting that's been protected, and we don't want you to touch those on a day-to-day basis. Those are special case scenarios. So for HV4, which is grayed, and any of the other things that you're going to be seeing that are grayed out, don't worry about those guys. You're not supposed to touch them, and you don't need to. So now let's go to HV5. 5 clicks up. 5 more. We've lost some intensity there. Now let's go back to our original. And then we'll skirt around a little bit. And again, it looks like some of this is not all that I'm doing, so I always wait for it to stabilize when that's the case. I'd like to add another note about HV5, and that this particular one impacts peak shape quite a bit. So the higher you bring up HV5, most of the time the better and more mesa-like your peak will become. However, it will lose a little bit of our signal as it does that. So there's always a trade-off with HV5 for signal versus peak shape. So just be aware of that. And a lot of times I'll just tune with a full peak with HV5 and find the best shape I have after I've already gone through these settings once or twice. So I'm just going to find the sweet spot. We'll just tune for signal intensity this first round and worry about peak shape on the second round. Let's move to HV6. 5 clicks up. 5 more. Definite signal loss. Let's go back to our original. And then let's go down. And again, we have signal loss. So let's go back to that original set point. Maybe we can do a little bit better. Let's try a couple clicks in each direction. That looks pretty nice. All right, so that concludes our high voltage for the first round. Remember, HV1 is a midpoint setting, so you're not clicking up and down that way. You're actually typing in above and below 30 of a midpoint. And then HV5 really affects peak shape. And those are the big ones for high voltage. So now let's move to our source slits. For source slits, we're going to be clicking up and down. We're going to just click all day long. So let's do up 5, up 10, and then down 5, down 10, and see where we're at with source V1 to start. looks like maybe we got a little better, but let's go back to that original setting. So yeah, I think let's just go up those 10. That looks pretty good. Maybe let's go 5 more to confirm. Nope, let's go back down 5. Let's move to source H1. And then let's go back to that midpoint. Or I'm sorry, that set point. And then let's go down. If any time you feel like you can't tell big changes, feel free to really change that value quite a bit so you can come back from a place of confidence. So I like to get things a little bit out of whack and then bring them back in so I can convince myself I'm actually doing something. So this looks pretty good. Source H2, you're going to notice big changes really quickly. You don't really need to go out very far to see changes with this guy. So I usually only go a couple clicks in either direction, and I'll start to see some big changes. It's really clear to tell for source H2 what the good midpoint is, where your stability is. So it looks like -31 or -30 are giving us really similar results. Just pick your favorite if that's the case. We're always going to go through our tune settings twice. So transfer H1. Then we'll go back. Then we'll go down. And then we'll go back. So it looks like that 39 may be our sweet spot. So let's move on to transfer V1. And there's not a lot of changes with any of these transfer lenses, so don't get discouraged if you're not seeing a lot that's happening. It's pretty normal. So transfer V2. All right. Even I have trouble figuring out what the best settings for these guys are. So we'll just put it there at -30, or I'm sorry, -29. So now that you've gone through your torch position, your high voltage, and your source, you're going to want to look at that peak and see how we've modified it. So we're going to go back to restore range and see what we've done to our peak. Hopefully you have a much higher signal, and hopefully we've actually improved the peak shake by getting those settings closer to a value that's operating in our range today. So we have a much flatter top, slightly sharper shoulders here, which is great. But we still have quite a little slope here on our sides, good angle. And remember, like I said, the perfect peak is basically a mesa. So maybe we can get rid of this slopey sides in this next pass. And that's probably going to have a lot to do with our quads, and it's going to have a lot to do with our HV5. So at this point, once I've tried to maximize signal, I'm going to go to quads. Now, quads are something that really affect peak shape, and they're something that you may need to adjust first rather than last, depending on how new your settings are and how much you've changed in the instrument once you started tuning. So after big changes like tube changes, cone changes, glassware changes, that quad is going to be the first thing you're going to touch rather than the last. But when we're pretty close to a good tune, we don't need to adjust that just yet, because what usually happens is you bring your quads up, and we don't want to bring them up unless we really need to. So I always go for signal intensity first. If my peak's pretty close, then I'll go to kind of change the peak shape a little bit. And everybody does it different. As long as you have a beautiful tune setting at the end of the day, that's what counts. But we'll just start with our quads now for our peak shape changes. what you'll see is quad 1 is sitting at 48.8, which is pretty high already. I don't want to change that very much, so I may bring it up just 1. And I'll see how that'll change my peak shape. We've lost some of this angle here on the shoulder, but we've kind of added a curve here. So let's watch it one more time. It's always good to see 2 passes when you make those initial changes. Good. And then the next thing I'm going to do is I'm going to bring my linked quads, these lower masses, underneath my high masses, and I do that using linked quads. It's right up top of quad 1. And what you're doing with linked quads to figure out what direction is you're going to move them whatever direction your low masses need to go. So my low masses, these guys, need to move left, so I'm going to click link quads left. It usually takes a couple to 3 to get those guys to line up. I always start with 2 and then I'll go 2 or 1 more and do it very gradually. You can always go back. Let's move them over a couple more. And what you'll notice is that we kind of lost whatever we gained with moving our quad in the first place once we kind of stack everything up. So maybe quad 1 isn't the one that's going to be the game changer today. And every day is a new day with this stuff, but quad 1 and HV5, you're kind of just pick your one to modify first and then see which one does a better job. So we'll leave quad 1 there. Most of our masses are lined up. Now what I'm going to do is switch to high voltage, and I'm going to go to HV5. I'm going to click HV5 up 1, because remember, when you move up, you usually improve peak shape. And we're just going to watch how it changes. So we've lost a little bit of that shoulder, so I'm going to move HV5 up 1 more. We're getting a little bit less shoulder again, so maybe 1 more. But what I am noticing happening is we're kind of losing our flatness here, so I might back off on HV5 just 1 or 2. And like I said, you can always go back to original settings to see if you actually have changed something you want to change. And if I'm not really sure that HV5 is moving in the right direction, I'll move it a lot. I'll click it up 4 and see how that changes my peak. So I've moved HV5 up quite a bit, but you'll see that our peak shape is so much more improved than before when we just moved our quads. And I could have moved quads way up. I could have fixed this peak shape by moving quads very high. But I want you to know you don't have to do that, and it's not the right answer when you're trying to fix a peak shape when your quads are already quite high. So if you can help it, move HV5 before you move quads way up there. So I'm actually going to try HV5 one more time to really optimize that shape, see if we can get it any better. It's already looking pretty good, but it looks like we still have a baby bald top here, kind of rounding a little bit. So that might look a little bit better. If you're getting a little noise in your signal, sometimes you can switch over to this integrate rather than single. And what that does is it'll integrate your signal for as long as you run on the passes. So if I switch to integrate, you would see your first one, which would be the only single scan. And then as it came around and passed over it again, you'll see this cycle number 2, so it's going to be the average of these 2 passes. And you could keep going to, 100 passes. But we usually stop at about 4 to see general peak shape without noise. So we'll give it a couple more passes to see how it actually looks. But to me, there's still a little bit of rounding, which I'm which I'm not super into, so we're going to try to take care of that a little bit more. We're getting very close though. All right, so let's go back to single. And let's look at that peak. And then we're going to peak center, and we're going to go through all of our tune settings one other time. We always tune twice at minimum. So we'll go ahead and peak center. I'm just going to do all of the same steps we talked with you before about. So I'm going to find the midpoint of HV1, make sure it's still 6018. And it looks like that may not be true anymore. Got quite a big jump there, so let's change that. Let's try 19. So it looked like 6019 was a pretty good midpoint, but let's confirm that. 6049. And then 5989. And that's a pretty small dip. So let's go with that. Generally, HV1 on your first pass always changes by the second. That's pretty normal. All right, let's move to HV2. It's already pretty high, but we can go a little bit higher if we're brave. But it doesn't really seem to be changing much, so let's bring that back down, and let's bring it down even more. No. So that's sitting fine. Let's go to HV3. And you can move a lot faster on your second pass because you already kind of know where the sweet spot is. Now you're just making really small changes. So sometimes that can be more difficult to see, and if that's the case, if you're having a really hard time discerning change, what you can do is go to your scale for 238 and get that 238 line much closer to the top, so you can really see when you're kind of hitting that max out line. So we could go, 1.9 instead, and I'd get it much closer here so I could see when I'm actually improving. And that's always an option if you can't see if you're making enough changes. These spikes happen again along the crystal. Since it's a heterogeneous crystal, there's different sections of the grain with different chemistry. You'll see some spikes for certain elements. So I see 2 spikes, so that's a 204 spike. And in general, our ion counter peaks for Faraday routines are very noisy anyway. So I just make sure they're underneath our major masses and that they're fairly flat, even though there are going to be a lot of noise in there. Let's just finish up HV3, make sure we're on the right track. That looks pretty good. Now again, I'm moving to HV5. Now I feel like I'm in the right place. I may gain intensity by changing that, but I may not gain peak shape. So I'm going to move it around, but I'm going to make note of this value if I need to go back to it to get my peak shape looking much better. And like I said, every time you bring HV5 down, you're going to increase your signal intensity. That just may not be the right choice. Just depends on what's going on that day. All right, let's move to source. Just go through our tune one last time. While I'm doing this, I'll just tell you another great strategy is to actually look at your peak after you change each one if you want to see what they're doing, and you're not confident that you're doing anything, which it feels like that some days, don't worry. So if I were to go through all of my high voltage units, maybe I'd go check out my peak shape right after that so I can see how those changes had affected my peak shape. Or as I go through each one, I can go check my peak shape and see how it's changed. And that's a really great learning technique that you could try as you're kind of learning how to tune and getting a feel for the new. It's something I had to do just to get things locked in. So don't feel like it's redundant. It's not. It's always good to see how changes you're making are affecting the instrument. All right. So let's check out that peak shape. I've gone through everything. We haven't gone through torch position. We only go through torch position once. Once your torch is set, it doesn't really change. And in fact, anytime you make a torch position change, you need to go through all of your tune settings again. It's a big factor. in peak shape. So if you decide later on that maybe you didn't do a great torch job, don't do that at the end. Do it at the beginning, and then you'll have to go through all the other stuff anyway. So kind of leave that for the beginning of your tune session, not the end of it. But we're looking pretty good. We have the tiniest rounding happening at the top, but we have some nice, pretty approaching vertical sides. I wouldn't say they're vertical. I'm not delusional. But we still just have some rounding here. And I'm going to adjust HV5 to see if I can take care of it. And if I still can't take care of it with HV5, I'm going to go back to our quads. Looks like we clipped some of it down, but I always like 2 passes. And maybe let's do 2 more jumps up just to see if we can really get it better. I feel like we're losing this edge, but let's make sure. Let's watch it one more time. Yeah, let's bring that back a couple. Just a little note, there's this dip happening in thorium, and you may start to see it in the 238. And what's happening is you're moving a little bit out, too far out on your slits at that point. So you're not really centering on them anymore. You're outside the range and it's clipping the signal. And that's how you know you're pushing it too far with your quads. You're pushing it too far one direction, as you'll see this little clipping motion. Those are good indications you've pushed things too far. Other indications is you've changed a lot of settings and you didn't change anything in the instrument. That usually never happens. Usually big changes in the instrument have big changes on the tune. If no big changes have been made, and if none have been made, and it's not an old tune file, you shouldn't be changing quite that much. So, always go back to your original and make sure that you're not, not getting too overzealous. So this speed is close to perfect, but it's not perfect. So what you'll do basically when you're pretty close, but not close yet, is just continue to go through those tune settings. And at that point, you may want to do what I'm saying, where you're changing a couple settings, looking at your peak. Changing a couple settings, looking at your peak. And I've already told you the big ones, quads 1, HV5. Another one that will shift your peak left and right is sorts H1. You can see how that affects your peak. But really, iteration is what counts with tuning in the new lab. So if it doesn't look good the first time, just try it again. And the very last thing that we'll do once we have our tune as close or as good as we'd like is to then adjust any gas settings that we feel might need to be changed. Now, we've honed them pretty well, but things change. Every day is a new day. So it's good to go over to your mix gas, your argon, your sample gas. So our mix gas is sitting at 105. That's what it was for our whole tune setting. But I'm just going to see if we can do a little bit better in terms of signal intensity, but also signal stability. So mixed gas, because it's actually carrying our sample gas, as is our helium that I'll show you on the laser side. Are there important components to check in with when you're tuning? So is 105 the best? I don't know. Let's change it to 104 and see how that changes our signal. Now that I've had some time to look at 104, I'm going to go back to 105 and see how they differ. Now, if I can't see any changes, I usually go with the one I tuned on, just because it's probably been the setting that's been working the best. That's why it's saved that way. But let's go up to 106 now, see how that looks. Just so you don't psych yourself out. If you are seeing really giant changes, again, check your crystal. Make sure you're not going over an inclusion or a crack or crossing another raster line, which is pretty important when you're looking at mixed gas, because it does affect stability. So just make sure it's actually what you're changing and not integrity of the crystal that's affecting what you're seeing. So I'm going to move back to 105. I like it much better. It seems just as stable as all the others. It's a little bit higher than 106 and 104. I couldn't tell the difference. So let's stick with a mixed gas of 105. Now we're going to look at the laser side and look at MFC1 and MFC2, which is our helium carrier gas coming directly from the laser. This mixed gas is coming from our argon that's just meeting up with the helium in the torch box. So they're both meeting at the torch head though, so we need to check both. MFC1 currently sits at 0.1 liters per minute. We're just going to go up and down a few clicks to see if we can improve our signal. So just verify on the laser computer that your little arrow is where you need it. And now I'm going to start to go up, and I'm going to watch my mass spec screen to see any signal changes. So I'm not seeing a lot going up, so now I'm going to switch to going down in the liters per minute and watch the signal on the mass spec computer. Looks like we're gaining a little bit more. And I always like to give it a couple seconds before I decide that I'm in a good place, just because it takes a while for the material to actually get to the collectors as you change that carrier gas. So I'm pretty happy with that, but I'm going to go up again just to confirm, make sure I really am in the best spot, and I'm going to go down. And it looks like 0.097 liters per minute for MFC1 is going to do the trick. Now let's switch to MFC2 and change that. That currently sits at 0.3. That's pretty standard running. So let's just go up, and we'll watch our mass spec computer to see if we see any changes. That is not the right direction. Let's go down. We'll watch our mass spec computer. Still not looking great. I'm going to go back to our original setting of 0.3 and see if that improves it. We'll go up. We'll go down. If you're not confident that you're actually making any good changes, feel free to just leave it at standard running settings of 0.1 for MFC1 and 0.3. I think for today, since I can't see large changes, I'm going to leave MFC2 at 0.3. Then we're going to go back to restore range on the mass spec computer so we can see that full peak. One important thing to note on the laser software is that when you go from right to left, you'll always have a signal reduction. It's an artifact of how the cup and the arm and all of the gases flowing through it work. So if you've noticed, 300 millivolts of signal drop and suddenly you're just going right to left versus left to right, don't worry. That happens to all of us. It's a bummer. But once you're going left to right again, it'll be fine. So I'm not terribly worried about the fact that I lost 300 millivolts. What I do know is that my peak shape is pretty flat. I barely have any shoulders, and we're approaching a more vertical face than we started with in our original tune on these sides here. So if I were you, I'd go through it one more time. You guys know the steps by now. Once you're satisfied with that final peak, you'll go stop. You'll peak center, and then you'll exit out of this magnet scans window and then save that tune file, and we'll go over how to save it. So now we're ready to save our tune. What we do first is drag our vertical line to the middle to peak center. Now you're going to notice that some of these peaks aren't perfectly lined up, and they're never really going to be. The higher masses are never going to be perfectly under the lower masses, and the ion counters are always just a little bit off. So you just find the point at which you are in the flattest section, the most middle of each of those peaks. So if that means you're a little bit to the right on the ion counter peaks, that's okay. You mostly want your uranium and all of your leads to be pretty symmetrical. So the ion counters may be kind of shifted, and that's all right. So this is, to me, my best midpoint. I'm on the flattest part of all of them. So we'll leave our peak there, and we'll just exit out of the magnet scans window. And then we're going to go to save it. To save it, you'll go back into Setup. You'll go to Constants, Tuning, Save. Now you're going to just save it with the same initial extension, so uranium, thorium, lead, Faraday, but you're going to add the date, any notes you might have, if you change something, if there's a new setting, either, and when I say setting, I'm not talking about a new high voltage, I'm talking about it like a very large setting, like you change cones or you change the ion pump or you had to, do a procedure you don't usually do. Those are for your notes section. So I'm going to add the date. We didn't do any major changes, so I'll just add my initials at the end. So today is the 11th of May, 2018. And my initials are CW. And then you'll save. And now that tune file is saved. You can always go back and tune again, never feel like you can't tune more than once. And if you wanted to start from a new tune file and see if you got close to this original tune, you could do that as well. So anytime you feel like there's room for improvement, always feel free to go back, make adjustments, save a new tune file. It's always best to never overwrite any tune files, because you may have made an adjustment that you want to go back and see later on and track changes of. But that concludes tuning. Now it takes just a second for sample to get through to the detector, so I always give it, 1 or 2 seconds before I start changing it again to see what I've done. And it looks like we're maxing out our signal here, so I'm just going to change my scale so I can see what's happening. And we'll go back, and we're going to bring MFC1 down. And your operating range for changing this usually is about, 0.85 to, 0.113 on MFC1, since it always sits at 0.1 liters per minute.